Hello, my name is Simon Timpley from the International Food Safety and Quality Network. It's lovely to be here today to bring you another Food Safety Fridays presentation. Today, it's food process improvement using statistical process control. And our guest presenter is Anne-Marie Joyce from Safe Food 360. Good afternoon, Anne-Marie. How are you doing?
Hi, Simon. I'm good.
Yeah, nice to have you along today. First time with us.
Yes, first time.
So everybody go gentle with Anne-Marie. Say hello in the sidebar. Tell us where you're joining from today. Myself, I'm in Manchester, a city in the north of England, and it's well known for its rain. It's not raining today, but it's a bit blustery and miserable. And where are you, Anne-Marie?
Yes, I'm based here in Dublin, Ireland, and it's typical Irish weather, cloudy and rainy, and a bit cold.
Well, snap, we're together. So anyway, it's great to have you along, Anne-Marie, and welcome everybody. I'm going to play you the sponsors ads, which take a couple of minutes, and then we'll be back for the presentation. Just firstly, it is being recorded today. The slides, recording, and your certificate of attendance will be issued afterwards. So don't worry if you miss a bit. So here's the sponsors ads. I'll see you shortly.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, we're back. Thanks to the kind sponsors of Food Safety Fridays that make these days possible. Okay, we'll get the slides up. I'll be back for the Q&A later, but for now, I'll hand you over to Anne-Marie for the presentation.
Perfect. Thank you, Simon. So today, everyone, we're looking at Statistical Process Control, or SPC, and how it can be used to improve processes you have in your facility or within your business. So what is Statistical Process Control, or SPC? So SPC is a method of quality control which employs statistical methods to monitor and control a process. So this will help to ensure your process operates efficiently and you're producing more spec conforming products with less waste, rework, or scrap. And really, it will mean you're sending out more spec conforming products to your customers, meaning you're going to get back less complaints. SPC can be applied to any process where the conforming product output can be measured, such as on manufacturing lines. Key tools that are used in SPC include run charts and control charts. We will see some examples of a control charts later in the presentation. And SPC will give you insight into valuable data which wouldn't be possible when you're using single data points. So a typical food business collects large quantities of data from their monitoring activities, such as CCP checks, receiving inspections, checks on final products going out. And usually all of this data that is collected is just filed away and nothing happens unless an auditor comes along and we need to pull some data out or some records out. So with SPC, you can really take the data and see what's happening. Are your processes capable of producing spec conforming products? So what are the benefits of SPC? Well, it will help reduce variability. We're going to see and talk a little bit about variability throughout the slides today. It can help improve productivity, reduce costs. Again, you're going to be doing less rework. You're not going to have to deal with as much customer complaints coming back in. It can uncover hidden process personalities. So, for example, perhaps you're producing burgers and they need to be within a certain specification, let's say 10 to 15 grams. But with SPC, you can find out, perhaps you may be now producing burgers at the higher end of the spec. So they're all within the limits, but it's on the higher end. So you can uncover hidden process personalities. SPC will allow you to then react to any process changes that you actually can see and inform decision making and improvements you will gain from this. So really, SPC allows for early detection and prevention of problems, rather than just correcting them after they happen. So SPC as a requirement in food safety. So recent changes to several standards are actually driving businesses towards identifying and using SPC or other statistical analysis tools to make better use of collected data arising from monitoring and control activities. One such standard is SQF Quality Code Edition 8.1. So in 2.5.4.3, the requirement there, it discusses that SPC methods shall be used to effectively control and optimize production processes to improve process efficiency and product quality and to reduce waste. It specifically mentions that control charts shall be in use for control of key processes and have defined upper and lower control limits. Now in there it says ±3 standard deviations. We'll talk a little bit about that as we go along today. But SPC is asking you, SQF is now asking you to employ this and use this to improve your processes. Another such standard looking for you to analyze your data to drive improvement is ISO 22000. Now, it doesn't specifically mention you need to use SPC, but it does say you need to use statistical tools to improve your systems. So we can see now that this is becoming more popular, not just creating products to spec, but driving improvement as well. And I am of the view that we will see other standards begin to bring this in as well, such as perhaps BRC. So where does SPC come from? Let's take a look. So here we have William Edwards Deming. He is considered the father of SPC. Now, before Deming, there was a man called Walter Shewhart who worked in Bell Laboratories over in the US of A. And he was really, he came up with the concept of SPC. However, it was his colleague, Deming, who really championed the work of Walter. So Deming, he is an engineer, statistician, professor, among other things. He has developed sampling techniques which are still used in the US Department of Census and Bureau of Labor Statistics. He's best known for his work in Japan after World War II, where he promoted the use of statistical tools in the rapid development of the Japanese economy and manufacturing industry. And today there are lots of different brands that we recognize as really high quality. And again, it really stems from his work and improving the Japanese economy and the manufacturing industry. So for example, we all would be familiar with Toyota. So Deming was an advocate that understanding your process and what you're doing is so important. And we're going to talk today a little bit about this here. So it's argued that a knowledge of variation and the range and causes of variation in quality and the use of statistical sampling and measures was a powerful tool for business. And again, we'll see a little bit more today about variation. So what is process variation and process data? So all processes have variation. And variation is the inherent tendency of a process to deviate or move around a central mean point. And Deming mentioned that uncontrolled variation is the enemy of quality. Now, we find variation all throughout nature: human height, weight, atmospheric temperature, and so on. So if we were to actually line up a bunch of people and take their heights, we'll find that most people fall in around the mean. We'll have some tall and some small people then as well. So variation is all throughout nature. It's impossible to eliminate it, but the objective is to understand and know the degree of nature, the degree and nature of variation. And once this is done, it is possible to control variation. So this is what you would employ into your processes, to know and understand the variation of the process. Every process has a typical or normal distribution around the mean. And if we take a look to the diagram here on the screen, this is a bell curve or a normal distribution curve. And in the middle, we have the mean. And with a process, usually a lot of the result or readings will fall around the mean point. So usually about, let's say, 68% of your results will be plus or minus 1 standard deviation in here. So remember that with this, the result should fall within plus minus 3 standard deviations. Sometimes readings will fall toward the tail ends of this curve. And once you know what your process actually looks like, and then you will be able to know whether it's in or out of control. So it's really important to understand your process data. All processes and food safety systems give off data, and we need to understand the degree and nature of variation of the process. And to do this, we need to collect data. And so Deming has also mentioned that without data, you're just another person with an opinion. In food processes and safety management, data comes in many forms. We have process parameters like time and temperatures and pH, audit results. So when you do your daily GMP audit, it's a pass or it's a fail. Non-conformances, CCP monitoring data, such as temperature, and sanitation and cleaning. And data comes in 2 forms. Variable data, such as temperature, pH, weight. These are all numerical. And we also have attributes. Attributes are non-numerical. So, for example, color. So maybe you're checking the color of bananas going out to the customer. And another example of an attribute would be metal detection. So either the metal wand is detected or not detected. So this would be an example of, an attribute. So most of the data collected by food businesses is for evidence of compliance. So let's say we check the weight of burgers and check the spec. Yes, it's in spec, or no, it's out of the spec. And that's all that's really done. So very little is used really for understanding the processes or driving improvement. And I guess that's where a lot of the GFSI standards are now beginning to realize and bring SPC into it. So there's just a huge missed opportunity with all this data that businesses are collecting. If you were to analyze it, you get a really good insight into your process and what's happening. And Deming said, without data, you're just another person with an opinion. So what do we measure? Well, in order to understand and therefore control your processes, you need to collect your data. And this means you need to monitor and measure. And this is the principle of HACCP, so Hazard Analysis Critical Control Point. In food safety, you will monitor based on 2 requirements: compliance to regulation and to customers. And then we also have risk. Risk assessment is the key and is reflected in most food safety standards. For example, thermal treatment process to kill pathogens. It needs to be a minimum time and temperature. It's necessary to determine if, at the set point, the process is capable on achieving the required kill based on variation of the process. And only measuring and collecting sufficient data and analyzing it will allow you to fully determine, is your process capable of always being able to kill the pathogens to the required time and temperature. And Deming said, you can't manage what you don't measure. So using your data to understand your process. Once you collect your data, either you determine if it meets the specification, and as I mentioned, that's what most people will do, or you can analyze your data using statistical techniques to describe the process in terms of capability to meet the specification consistently. So while you may actually be, let's say you check the weights of 10 burgers every hour, while you might check the weights and they're within the specification, something else may be happening. There may actually be a shift in your process. And that's where SPC comes in to allow you to quickly see if there's a shift or if there's something happening. So just because we're making burgers to the correct weight doesn't mean that our process is capable of always meeting the spec consistently, and that's where SPC comes in. And again, Deming said, if you can't describe what you are doing as a process, you don't know what you are doing. And he is right. Now, there are some barriers to collecting your data and analyzing it. Yes, you're going to need some tools to help with this. You might need to know a little bit about SPC in order to interpret the data. And yes, it might require a little bit of time, money, and resources. However, the benefit is huge. If we take a look here at the diagram, we can just see some different types of processes. So the little black line at the bottom, this has a wide variation. So this would indicate your process is not very capable of consistently producing in-spec products. Next, we have the red line. This is an example of really an acceptable or perfect process, well capable of producing spec-conforming products. The green line, quite tall, quite skinny. This is a tight variation, and we're highly capable of producing products to the spec. However, when you've got such a tight variation, it doesn't leave much room. So while this is good, again, we have to be careful. So understanding your data. So once data is collected, you can use standard statistical tools, and the data will tell you a story. Either we have a normal process, so it'll be the normal distribution curve. We need to see, is the variation capable of meeting the spec within that ±3 standard deviations? And is there a bias or any skewing in the distribution of results? And we can then see, are there any trends above or below the set point, which may indicate a shift or a possible loss of control? So specification versus control. Let's take a look at this. So when we're measuring performance, there's two ways. Either is the process within spec, or is the process in control? So when we're measuring to see, is it in spec? This is just a basic approach. We're just taking a sample, measuring it, and comparing it against a specification and deciding is it pass or fail. So for example, for pH, maybe the spec is between 5.5 to 5.9, the result is 5.7, and so we're in specification. It is a valid approach. However, it only takes into account one data point and does not take into account variation. And therefore, while we have 5.7 here as a result, if we look at the bigger picture, there may be out of spec results that are not detected. And again, Deming mentioned that meeting the spec is not enough. So in control, this is all then based around SPC. This approach is usually based on a detailed capability study designed to determine the process variation and its capability to stay within limits. It takes into account the probability that the observed mean and range of a sample size is as per the normal process and therefore in control. And in short, this process will tell you, or this approach will tell you if the process has shifted away from its normal variation and if it is likely to produce out of spec results. Let's take a look now at control charts. And before we do that, basically, what does SPC like? Well, SPC, or Statistical Process Control, prefers not to use single test data. So what does that mean? Well, let's say we are checking the weight of burgers coming off a line, and every hour we check, let's just pretend, one burger. So we'll check the weight. So that's really a single test data point. And what SPC likes, it's to work with bigger sample sets. So maybe every hour we need to check the weight of 15 burgers. So that's what SPC likes. It likes to have big sample points. SPC likes to use statistical formulas to determine the variation of the data around the target, and also to determine if variation is within control limits. Control charts are typically used to plot this data over time to track the process mean and range. And there, as we mentioned already, there are different types of charts for different types of data. So for variable data, we have an X-bar chart or mean chart, range or chart, and also an S chart, which is a standard deviation chart. We're going to look at these now, but also for attributes, we have what is called a P chart. And as I said, we'll focus just on mean and range today. So here's an example on the top of a mean chart, or an X-bar chart, as it is sometimes called. And on the bottom is a range chart. So with SPC, let's pretend you collect data. If we put this data in and create an X-bar chart or a mean chart, and then we take the same data and create a range chart, they could tell a different story. So let's take a look now at just some formulas that we might see usually within SPC. Now, we won't go into great details, it's just to introduce all of these to you. So here we have N. This is the number of samples or test readings taken at a given point. We have mean. This is the formula for mean. We won't go into details there. It does look quite complicated there. But the mean we need when we're doing SPC analysis. And the mean is when you take all of your results, add them up, and divide by the number of sample points that you have. Next, we got range. What is range? Well, let's pretend you take you check the weight of, let's say, 20 burgers every hour. To get the range, you take the lowest value from the highest value, and you've got your range. Then we have standard deviation. Standard deviation is the measure of your results around a mean central point. So it's basically the measure of variance around that mean central point. Summation. So this is just the total sum of all of your values. So these are some formulas that are usually used within SPC. So control charts will allow you to answer certain questions, such as, is my process stable over time? What is the effect of a process change on the output characteristics? And how will I know if the process becomes unstable or the performance changes over time? So here is an example of that distribution curve, or the bell curve here. In the middle, we have the process mean. And we got on the sides, -3 standard deviations, +3 standard deviations. So when you're collecting your data will be plotted, you know, and you'll then be able to see whether you're falling outside of this. So here we have it here. This would be an example of, let's say, as I said, maybe you come along every hour and you check the weight of your burgers. So the data will be plotted along here, and then you'll begin to get a trend. On the top, we got your upper limit, on the bottom, the lower limit, and in the middle, the mean. So as I mentioned earlier, with SPC, there are lots of different charts. Usually we have an X bar and an OR chart. These are used. And here we can just see that we got the upper control limit, central line, that's the CL, and lower control limit. Now, these aren't upper spec limit and lower spec limit. This is upper and lower control limit. So again, with the analysis, this is basically your ±3 standard deviations. That's what this is. And if you were collecting the data, there's formulas to allow you to calculate all of this. So next, we have here the range chart, so to monitor the range and change over time. Again, we got the upper control limit, central line, and lower control limit here. So the results are just plotted in here. There's also standard deviation. So in here, again, we got the upper control limit, central line, and lower control limit as well. So let's actually now look at this in action. So what would an SPC report actually look like? So we have, first of all, data type. Is it variable or attributes? Depending on the data type, you'll get different charts. You use different charts. We got status. Is it out of control or in control? And sample size. Now, depending on your sample size, you'll use different charts. Then we have the spec limits, so the specification limits. So here we got the upper spec, 205, target 195, and lower 185. And at the bottom there, we have standard deviation. As I said, the standard deviation measures the average spread around the mean. We got their CP index and CPK index. These are important. This is the measure of how capable your process is on producing spec-conforming products. Now, we won't go into too much details, but CP is all about capability to produce within the upper and lower spec limit. Whereas CPK is a little bit more about performance. Yes, how capable are we to produce within the limits, but how capable are we to actually produce to the target as well? Then we have here the distribution curve. So we've seen an example of this today. So as you take your results, they can be plotted, and then you'll hopefully see a nice curve. Then we got some analysis here. We got the process mean, the upper control limit, center line, and lower control limit. Now, these are all calculated based on your data using, SPC formulas. We have in here your X bar chart, so we can see it here, and your OR bar chart as well. So the data is plotted. So the X bar chart might say something different to the OR chart. So that's why it's important to employ this, because you'll be able to see what is happening. So I want to talk to you and go through conducting cleaning validation, because you can employ SPC to validate your cleaning. So if we were to do that, what do we need to begin with? So first of all, you need to do some pre-validation tasks. So identify your hazards, listeria, whatever it may be, the risk assessment, prepare your standard operating procedures or your sanitation standard operating procedures, prepare cleaning schedules, validate procedures, and of course, train everybody who will be involved in the cleaning. So that's where you would begin when conducting cleaning validation. Next is the approach. You need to make sure you collect data, scientific data. Data on hazards and risks, legislation, very important to do your due diligence on chemicals you're going to use, and how you're going to analyze the data, say maybe the swabs that you take. Then we have parameters and decision criteria. We need to define the microbiological, allergen, and other relevant criteria necessary to consider SOPs to be validated. Then we can conduct the validation activity. So implement your SOP for a specific period of time. So let's say 3 to 4 weeks, which might be 10 cleaning activities. Then we need to do the testing of food contact surfaces after cleaning and disinfection. Next, then we analyze the results. We collate the results and we conduct appropriate statistical analysis to determine the variability in efficiency of the cleaning SOPs. Basically, a capability study. So how capable are we of doing the cleaning and it being effective? Let's actually take a look now at a capability study for cleaning. And of course, there's either going to be one of two outcomes. We're very capable or not capable. If we're capable, then we validated our cleaning. So when you're doing a capability study, first you'll define your upper and lower spec limits. We got 0 to 200 RLU here. And what is the target? Then what you do is you will obviously do your cleaning, then do your swab analysis and plot the results each time. So hopefully when you do this, you will then begin to see a trend. And you can see here, there's a slight yes bell curve. However, if we take a look, we are getting results outside of the specification limits. So we can see to the left and to the right, there are some results that are outside. So this is an example of, it's just not capable. And here is an example of where we are capable of conducting the cleaning and it working for us. So everything is within the upper and lower spec limits. And in terms of capability, CP and CPK index is what is used. We saw that just a moment ago. So when you're doing a capability study, you can use lots of different tools. For example, Excel with built-in formulas that you're doing your validation, and as you get a result, you can plot it in here, and it will then pop up in the graph. And also with formulas in here, you'll be able to find out what's your CPK, CP index, and so on. Now, I won't go into too much details, but, for CPK, and, ideally this would be around 1.33. And then for CP, hopefully this would be, ideally it would be in and around 1 or, bigger than 1. So then after all of that, you need to document the data in a validation report and prepare it so we can clearly present all of the information. And then in conclusion, if results indicate that the sanitation standard operating procedures are capable of consistently delivering results that comply with the established criteria during the period, then the cleaning SOP can be considered effective and validated. And if results indicate that it's not capable, then we'll need to consider the SOP ineffective, and maybe we'll then need to improve on this. So maybe recommendations should be made to redesign the SOP and repeat the validation procedure. So in terms of SPC, there are a number of useful white papers and blogs out there to help you. There's even here a link to a cleaning validation tool, like what we just saw previously, that you would be able to use. And again, this slide deck, I'm sure, will be made available to you. Lastly, now that we've come to the end of the presentation, just to remind anybody who might be interested, Safety 360 is doing a webinar on approved employees, visitors, and contractors with medical screening in using a Safety 360. So this is taking place next Thursday at 10 a.m. Eastern Time or 3 p.m. BST time. And again, the link will be made available to you for this. Okay, I think we're ready for any questions.
Yep. Thanks very much, Anne-Marie. Nice overview with a good example. Obviously, in a short space of time, we're not going to go into massive depth, but it's just a primer, SPC. There are a lot of facets to it, and it helps us to control our process and improve. Okay, so any question? Hamid, begin with a question. Francis. Okay, well, let me just see if we can see this one. Yeah, Hamid, if we collect data concerning the development of fruit color during processing as ABC Act, how can we take these data into consideration to SPC? That's. Yes. I don't understand that. Do you, Anne-Marie? Is it enough information?
So we didn't look at what is called a P chart. I think a P chart would be employed in this case. So I know it's a little bit different for, data like, the colors of the fruit coming in. The data is different. It's an attribute data. So again, you would employ a P chart, and basically, as you would be collecting all of your data over time, there are different tools that would plot this data, and then using SPC rules, formulas, will be able to tell you, information about, is this in spec or within control or out of control? So you can still, when it comes to the color of fruit, yes, you can still analyze this data. Yeah.
Okay. And Sagar, is SPC mandated in any GFSI benchmark standards? I know that SQF requires some elements of SPC under product sampling clause. Does BRC, IFS, FSC mandate SPC? You did mention SQF, but do you know, Anne-Marie?
So as far as I'm aware right now, BRC, IFS, FSSC 22000 don't specifically mention it. Now, ISO 22000 does, and I believe that's part of the FSSC 22000. But so far, ISO 22000 and SQF. Yeah.
Okay. Bupathy, is SPC preferred to be executed through software-based systems, or can it be done manually? I mean, like Excel.
Yes. Well, yes, you could do it through Excel. However, obviously, softwares would obviously be better. You can record the data so somebody can go around and do all the checks. It goes into the system, and the system will then automatically do SPC analysis on that for you. Yes, you could do it on Excel. However, somebody might be recording the result, and then you'd have to sit down and, well, that's my opinion, you'd have to sit down and perhaps put it into an Excel to analyze it. Of course, it can be done, but software would save you time in the long run. Yeah.
Okay. It just as a matter of interest, is there an SPC module in SafeFood 360?
Yes, so in SafeFood 360, we have a module called monitoring, where most of your production records are completed. So metal detection checks, temperature checks, quality checks. And as long as you're recording that data in our software, you get SPC analysis straight away. You don't even have to do anything. It does it for you within the system.
Yeah. I think back in the day, I used something called Minitab, which is, I don't know if it's still around these days, but is Vinod, is SPC important for food safety management system?
Well, if you want to improve your process and what you're doing, I'd say yes. Again, it's at the moment it's only required by, let's say, certain GFSI standards, but I do think there will definitely be a shift, in my opinion, towards knowing that your process works and improving. Yes. Yeah.
Okay. Okay. Let's have a look. Sorry. Bhupath is saying, is the sampling data, can it be automated? Depends on the tools you're using, I guess.
Mm-hmm.
Okay, various people are asking about SPC in packing fresh fruits and vegetable, brewing, etc., etc. SPC, am I right in saying SPC can be used and is valuable in any process?
Exactly. Yeah.
Yeah. But in terms of what you're going to control, it depends what's important.
Yeah. Exactly. Let's say you get in crates and crates of avocados, and you definitely SPC will be able to help you determine are we getting in or receiving materials that are within the specification and constantly or not, and then you can make decisions to improve on that, change supplier, and different things like that.
Yeah. Let's have a look at this one from Jeffrey. When evaluating the results of the validation study, how do you differentiate between an SSOP, that is ineffective, and OOL results resulting from a deviation from the SSOP.
Okay.
That makes sense to you?
So
yeah, so how can you differentiate between basically a procedure that's ineffective in of itself and or somebody may perhaps deviating from the procedure?
yes, so definitely, if you saw in the slides, the capability study that we were doing, once you're plotting the results of your, the testing, the swab analysis, you'll then know whether or not your cleaning SOP is working for you. Or, you'll definitely be able to see whether your results are going out of the limits. You will see on that there, the tool that I showed earlier, there's also a link in the presentation. You'll be able to clearly see if the results are going outside of the limits or not, and whether your cleaning procedure is capable.
Yeah. I suppose by being intimate with your process, auditing, monitoring, actually physically watching what people do, that will tell you whether, because people can always circumvent a procedure and not follow the procedure. So
Yeah.
You need to validate your results, I guess, that way as well.
Yeah.
Eves, when you were doing SPC study by collecting samples and a breakdown happens, breakdown of the machine, I guess, when can you resume sampling collecting after you resume production? I heard that you need to wait until all running parameters are back to where you were before the breakdown.
Okay. So when SPC analysis is when you're doing SPC analysis, yes, if there is a breakdown, yes, it's going to show on the details now, or on the charts. Wouldn't be 100% sure on whether you need to stop and then begin again, but you'll know this yourself. You'll know, okay, the chart is showing a slight deviation, and that's, we know it's because there was a breakdown. But yeah.
Yeah. I guess that just makes common sense that you need to get fully up and running again before you can, because it's part of the breakdown, I guess, and the ramp back up until you get stable. Minimums, again from Eves, minimum sample size you need to have for a good SPC study?
Yes, so ideally, I do believe that I do believe it needs to be, your sample size should be bigger than 10, I believe. I could be wrong, but it does need to be, the bigger the better, because then you can employ a different chart. So we saw today examples of the X-bar chart with the range chart, and that's when you've got a small sample size. But when you have a bigger sample size, then you are able to employ the S chart or the standard deviation chart. So that will tell you even more about your process. But yeah.
Yeah. You can be more confident of the reliability, can't you, of the results, the data, the more.
Exactly.
Vinod, how can SPC help reduce consumer complaints in food manufacturing?
Yes. So if you are producing product, and yes, it's within the spec, there'll always be something you'll miss. However, when you do SPC analysis, you will be able to see if there's any sort of trend happening in your process, and then you can prevent issues happening, and then therefore out of spec products ending up with to your customers. And again, with the SPC, you'll save in terms of having to do rework, and things like that. Less waste, hopefully. But yes, one of the big things is it can help reduce customer complaints in the long run. Yeah.
Okay. Apparently, in SQF 8.1, which is the latest version, they've removed the requirement for SPC.
Oh, okay.
So some users of SQF in the sidebar are more up to date with it. Perhaps it's been removed. Not sure why.
I'll have to look into that. Yeah.
Yeah, just to say, one or two people have been asking, is this being recorded? Can we get, yes, it is being recorded and it will be available afterwards. We'll send the slides and the recording, circulate it afterwards. Pankaj, how is SPC's role in trend analysis? What's the role of SPC in trend analysis?
Well, it will definitely be able to tell you what's happening in your process. So let's say you're testing the weight of burgers every hour. Perhaps everything you check is within the spec, but perhaps it's maybe at the lower end of the spec, so it might mean something. Maybe we need to, again, there's actually 8 rules for interpreting your data in the charts. I didn't go into them today. Again, there's lots that we could talk about, but you'll be able to see if there's a trend clearly. Maybe a lot of them are below your central line, and it could mean something, or maybe it's some are high up, then it's quickly down back to the bottom. It can, again, all of this trending will, that's SPC is using this and trending your results. Yeah.
I mean, as you mentioned earlier on, Anne-Marie, I think you mentioned this actually, we can't improve what we don't measure. And in food safety management systems, quality management systems, continual improvement, it's a way of life, whether it's for improving the products or reducing complaints, consumer complaints, waste, whatever. But if you don't measure that, then you don't know where you're at. An SPC, or the suite of tools with an SPC, is the toolkit.
Yes.
For doing that. So, this is a primer. Everybody's got their own process and particular distinct product process, etc. But the toolkit can be applied to anything. So it's worth looking into it further, wouldn't you say, Anne-Marie, for everybody?
Yes, definitely. Because, some people will just make sure what they're producing is within the spec, and that's good that we all do that. But you want to improve. You want to always make sure that your products are at the best that they can be. We want to save everybody time as well. I mean, if you're employing SPC, there'll be less for production managers to deal with, rework, and things like this. And we're going to save, everybody who saves time, our time can go elsewhere. So yes, you're correct, Simon. Yeah.
Okay, very good. Okay, just some comments. Thanks, great presentation. Thanks for presentation. Steve, are you going? Everyone have a good weekend. Let's hope so. Okay. Any more questions? I've got one from Kamel there. If we have many variables in just one process, how can we deal with this using SPC?
Yes, so they are all analyzed separately. So, for example, in certain softwares like Safety 360, maybe you are checking your products on dispatch. So you're checking the temperature, the color, if it was bananas going out to the customer. Well, that's an attribute, but maybe other variables as well, temperature, weight. You're checking all of this. Now, in softwares, it will automatically do the SPC analysis per variable. So it doesn't matter how many you're checking, you'll get analysis out for each individual variable. So yes, that's how it would work. Yeah, per variable.
Okay. Oh, and I know this every single time. Sorry, Anne-Marie. I've issued the certificate in the sidebar, and there's this blank space for the each attendee to add their own name, because I can't individually write 400 or well, in fact, 1,500 people registered for this. I can't. I'd be up all night putting your names in the certificate. So you have to either print the certificate and write your own name on it, or opening it in image editing software and type your name. JS is just asking, finally, last couple of questions, the importance of SPC in sustainability.
That's a good question. Definitely something I might do a little bit of research on. It's hard to tell. I mean, there's a lot of, you could maybe you have certain packaging for a product. You could do your research, find out something that's a little bit more, sustainable. I'm not too sure for that question. How to answer it. Definitely an interesting one.
Yeah. It's very broad question, difficult to answer. Right. Thanks very much, Anne-Marie. Neve's just said it there. Absolutely brilliant presentation. You explained the topic with such clarity. I've learned a lot. Cheers. Excellent. So there you go. So I'll use that one to sum up the comments of everybody. So really appreciate your time. Your first time with us here. Have you enjoyed it?
Yes, I have. Definitely. Yeah.
Very good. And we've enjoyed having you, Anne-Marie. So hopefully we'll see you again on one of these in the not too distant future.
Yeah, definitely.
Okay. Have a nice weekend, Anne-Marie.
You too. Bye, everyone. Thank you for joining.
Okay, thanks, ladies and gents. That's Anne-Marie Joyce from Safe Food 360. We'll send an email back to you all afterwards with the recording, the slides, and the certificate. Again, I mention it every time, print and sign your name on the certificate yourself, or open the certificate in image editing software and type it. I cannot personalize 1,500 certificates. I'm sure you can understand that. Right. It's been a pleasure to be here. We've had a bit of a gap of a couple of weeks of not having Food Safety Fridays, but we're back for, I think, probably the next 3 or 4 weeks. We've got one every single week. So keep your eyes peeled on your inboxes and sign up to those webinars. Click the registration links and also share it on social media. Share it to your colleagues, not colleges. So share it to Facebook, Instagram, YouTube, Twitter, or whatever. Yeah. Okay. Take care, everybody. Have enjoy the rest of your Friday. Keep safe. The world is crazy at the moment, but keep smiling, and we'll all get through it together. Peace and love.